was trying that one like over and over and like every single way and nothing was like I didn't get 1.74 like at all. So
Well,
I
so one of the things, yeah, one of the things I'm thinking of is you might need to convert the moles per liter to something. And I just I don't know. But I can look here. The amazing thing of the internet here is there's probably a similar problem.
Yeah, because I did another problem like that and I got it and I did it like the same way that we did this one and I got the right answer. So
Yeah.
I just think maybe he put that in wrong or something.
Yeah, let me check. That's the problem with the answer keys. If they're not right, they get students kind of like, what's going on? 1 point. Huh. Well, I'm not sure. Let's move on. You can.
Yeah, that's fine.
Okay, wait a second. So the next one's going to be, there's an issue with the next one because you're going to get the concentration. Okay, there's something about going from molarity. We could figure this out here. It's molarity to pH is what we're trying to figure out. Did you guys talk about rate laws at all?
I don't think so.
Okay. How about this? Hey, A, does that sound familiar?
Mm, no, not really.
Okay. Well, okay, well, let's look at another one here.
Mhm.
This always happens. It's just
Yeah,
not straight.
chemistry is really ugh.
Yeah, I was looking at some down the road, which down the page here, which were just concentrations and you can convert them. But here we go. So what is the molarity of an aluminum hydroxide solution with a pH of 12.8? So to get the concentration is 10 to the minus 12.8. But we have to look and see if that is actually the answer. I don't believe that it is. I believe that there's an extra step here.
Yeah.
You don't have any example problems from class?
No, he's really bad at it because he makes us like turn in all of our work, so I don't get to keep like any of my work. And he
Got it.
doesn't like post notes on like the teams that we use.
Yeah.
And yeah, it's really stupid.
So there's some numbers on the key for like there's all these other numbers. Any idea what those are for? Like the 3.98
Um,
times 10 to the minus 1, the 13.6.
3.9. Um, yeah, I don't really know.
Okay, give me just a moment here to look some of these up because I think I can find this.
Yeah.
So there's this formula that I keep seeing, which is that Ka equals 1.8 times 10 to the minus 5. And it equals the concentration of, for example, H plus, but then it's the reactants over the products. And that's where I keep wondering if we're missing something here that isn't quite right. So let me, because the minus the log of this is not the right answer, but what are they? There must be a sample problem here. Okay, let me take a look one more at this exercise sheet. Okay, let's just we're just gonna have to skip past this for now, and maybe something will come up later to answer this. So let's move to number 6. So the thing that I was hoping to bring up that is that molarity is moles per liter, right? And our molarity, molarity in this problem is 8.8. Okay, and we want 8 moles. So we need to figure out how many liters. And it's as simple as solving this equation now. You just have to solve for x. So to do that, we can cross multiply both sides by x. Probably multiplying both sides by x is the most common approach here. So it ends up being 8.8x equals 8. Divide both sides by 8.8. So x equals a little bit less than 1. And I'm really, really hoping that that is the answer, and it is, thank goodness. Okay, so we'll make a little progress here on this sheet. We'll go back to the other ones. All right, number 7. All right, what is the molarity of a solution made by adding 88 grams of aluminum nitrate to 880 milliliters of water? So molarity is moles per liter. We have 88 grams of aluminum nitrate. So I think that's like AL know something. So you got to know these as well.
Yeah.
So I'm using the internet, and ALNO3 like that. And then the reason I'm doing that is because we want to convert to the molar map. So grams per mole. So go to your favorite molar math calculator.
89 grams per mole.
All right, so about 89 grams per 1 mole. So this calculation gets you the number of moles. Then you've got to convert the 888 milliliters into liters. So there's 1,000 milliliters in 1 liter. But some students try to do those calculations all together. I recommend doing them right there. Do this one, top one first, then this one, and then you can divide.
I got .98 for the first one,
Okay,
and then 0.88, 888 for the second one.
I got a different molar mass for aluminum nitrate. There's
Uh,
three NO3s according to what
yeah,
I saw.
added, hold on, let's see, 20. Yeah, I still get 89.
So aluminum is 27,
Mm-hmm.
but and then there are three ends. So 14
Oh,
each,
that I didn't get.
and then there's 9 O's.
Oh, I see, I see. Okay. Oh my god, look at my calculator is 60.
So I got 213.
Um, yeah.
Okay, so the 88 over 213 will calculate, go out to a couple of decimal places. Yeah, I don't know, 4, 6, good numbers. It's 0.4131 over the 0.888. So you got 0.4653. And that's, it's moles per liter.
Okay. Okay. Yeah, I remember that. That makes sense.
Okay, let's keep going here. All right, next problem is when the solution above is made, the volume of the solution is 892 milliliters. What is the molarity? I don't understand that. So it's moles per liter. So I guess when it says above, I guess it's referring to number 7.
Yeah.
I don't know, that's weird.
It's okay. I don't think we're gonna have questions like this on the thing. So I think it's okay.
Well, the answer is really close. So I do see that it is doable. So for number 8, you take the moles, which you just found, 0.4131 moles, and you divide it by, you take the 892 milliliters, and then 1,000 milliliters on the bottom, 1 liter on top, so 0.892 to get the if you divide that, I believe you'll get pretty much the answer they've got there in the.
So, okay.
So the answer sheet, I think, says 0.463,
Yeah, I got it.
and that should be right about what we got there.
Yeah, it is.
Okay, 60 milliliters of water. All right, so up to number 9. Here. Okay, 60 milliliters of water is added to 20 milliliters of a 2 molar acetic solution. What is the new concentration? So again, you've got 2.0 molar, which is some number of moles, which we'll call
Mhm.
X per liter. And we know that We know that it's 20 milliliters, so we have to convert 20 milliliters to liters. 1,000 milliliters in 1 liter. 20 divided by 1,000 ends up being 0.02, I believe.
Yeah.
Okay. So that allows you to figure out how many moles. Okay. X moles, to figure out the number of moles is you take the bottom number, 0.02, and multiply both sides by that. It should be like 0.04 moles. That's not what it's asking for, but that's kind of the intermediate step.
Yeah, 0.4.
Okay, so now we're adding water, like imagine, just flask or something, pouring water in, fine. So what that means is that the moles don't change. So the new concentration, the 0.04 moles is not changed, but the 0.02, you're adding to it 0.06 for the other one.
So
So when you add those up, it's 0.08, you end up getting 0.5 molar solution. All right, so what that means is, like, if you ever want to reduce the molarity, you just got to pour some water, which should make sense.
Yeah.
We do that to dilute things all the time. Okay, number 10 or 10. All right, how many milliliters of water must be added to 50 milliliters of a 2.0 molar calcium hydroxide to make a final concentration of 0.25 molar? So you start out with 2.0 molar, and we know that that's X moles. We don't know the number of moles, but we do know it's 50 milliliters. So at some point you just get comfortable with the conversion. If you're not comfortable, you have to come off to the side here and say, okay, there are 1,000 milliliters in 1 liter.
So that's 0.5.
Yeah, 0.05.
Oh,
Right.
yeah.
And then for the next one here, you have to solve for X. You multiply both sides by 0.05. So can you give me the number of moles there?
Yeah. Okay. Oh, the computer. Zoom thing. Okay. Oh yeah. Okay. So. Is it?
It's
So
multiplying 0.05 times 2.
So 1.
0.05 times 2. Try again.
Oh, 0.1.
0.1 moles. Okay, now that's kind of like the setup. That's the first part. And then, okay, it's like, well, now we want a final concentration that's 0.25 molar, which is like the transition of the problem. The number of moles stays the same. That doesn't change. Now I'm just going to change letters. Y liters. Now we know it's already 0.05. So there's a couple of ways to do it. You can just look at Y as like the total amount that you're going to put in. Or I'm sorry, the total amount that's going to be there, and then we subtract out the 0.05. Or if you want to know, well, how much am I just adding? It's 0.05 plus Y, because you already have the 50 milliliters in there. It will be easier to just leave it as Y, but then you have to remember to subtract
Yeah.
at the end as well. So I'll show it this way, and then you can decide later on what you want to do. You multiply both sides by that y. All right, so you've got 0.25y equals 0.1, and then divide both sides by 0.25. Okay, you want to give me that calculation, please?
0.4.
Okay, 0.4. And that's in liters. Okay. And then we'd say, okay, if we go back to the problem, like we start out with 50 milliliters. And I think the hardest part is the conversion. Like 50 milliliters is 0.05 liters. So you take that 0.4 and subtract the 0.05. You need to add in 0.35 liters. And that could be a little bit awkward because you typically think of volumes as being whole numbers. So you can convert that back to milliliters. To do that, you say, okay, in 1 liter, there are 1,000 milliliters. So your answer is 350 milliliters.
Okay, I get that.
We'll move on to next one here. It takes 25 milliliters of a 0.1 molar sodium hydroxide to neutralize 50 milliliters of a hydrochloric acid. What is the concentration of the acid? Okay, so there's something about neutralizing. So I think that means it's the same concentration. No, that wouldn't make, because that's what it's asking for. All right, let me check on this. And you go to that again, you can tell me the same answer. You don't have any practice problems like these?
Yeah, no.
Oops. Wow, that went to the wrong screen. Okay. Okay, so it says to neutralize, you need the equal number of moles. So we need to figure out the moles of hydroxide. So we have a 0.1 molar equals X moles over, and it's got to be in liters. So you take that 25 and that becomes 0.025 liters. Okay, so can you solve this for X for us, please?
Is it 0.25? Oh. Yeah, I got that. I don't think I can hear you.
All right, sorry about that. Did you, we got the same answer, that 0.0025?
Yeah.
Okay, so now for like the next part of the problem, it's 0.0025 moles. So to neutralize the concentrate, the number of moles is the same.
Mhm.
Divided by the number of liters, it's 40 milliliters. That's 0.04 liters. That's your molarity. That's your moles per liter.
Okay, so 0.0625.
Okay, we'll probably check some of these. I haven't checked one in a while, but that is correct.
Okay, awesome.
All right, so we're flipping the page. Don't know if that's good or bad, but we'll take a look here, do the best we can. All right, if it takes 15 milliliters of a 0.2 molar hydroxide to neutralize 35 milliliters of sulfuric acid, what is the concentration of the acid? Okay, this is really similar to the last problem. We start with the initial quantities, and we say, okay, 0.2 molar is some number of moles per liter, X moles if we don't know. And then the liters part is 0.015.
Mhm.
Okay, so could you solve that for the number of moles, please?
Yeah. 0.03.
So it's 0.2. Hopefully you're multiplying by 0.2 and 0.015.
Oh, 0.15 times point. Oh, 0.003.
It's 0.003 moles. Okay, and that means in the new part of our problem,
Mhm.
moles per liter, we have 0.003 moles. We just are calculating moles and they're the same. And so this time it's 35 milliliters. So that's 0.035 liters.
Zero point 0.00857.
Uh, this is number 12.
Yeah. Point
If it takes
eight.
15 milliliters of 0.2 molar aluminum to neutralize 35 milliliters, what is the concentration of the acid? Okay, I see. There's the number, everything's been fine. Now this one, did you say 0.129?
No, it's 0. It says 0.00857.
Let me check here because we've been doing so well with these, and now all of a sudden it's off, which I don't understand. Okay, 0.2 molar, 15 milliliters, that's 0.015.
Mhm.
35 milliliters of a sulfuric acid was the concentration of the acid. Okay, same number of moles, 0.003 moles. Okay, So I'm not sure. The answer in the book, and at the bottom there, it says 0.129, which is, I mean, it's not, it's nearby, but I'd like to know why it's different.
Mhm.
So maybe you can ask about that one.
Yeah.
All right, so 13. 13 here, give me just a moment. I just want to check 13 before. We're checking something here. So we're back to kind of these problems where I'm not quite sure why these aren't working.
Mhm.
Molarity of a solution to the calcium hydroxide with a pH. All right, let me snip it in here. Maybe we can find a way. Not working. Okay. All right. So it says, what is the molarity of a solution of calcium hydroxide with a pH 12.2? So that means the pOH
Mhm.
is 1.8. And then the concentration you get, the concentration of OH or H3O plus is 10 to the minus 1.8. But we're not using this Ka value either.
Mhm.
Okay. So there's something I'm missing. These next problems, 13,
Mhm.
14, are related to the first few. So hopefully you can get some help in the
Yeah.
classroom for them. Let's take a look at 15 next, see if we can make some sense of this one here. It says, what is the volume in milliliters of a 0.6 molar solution of zinc nitrate with 90 grams of solute? Okay, so they're giving you the molarity. You need the number of moles, which you don't have currently, and you also need the number of liters, which you also don't have currently. Okay, but we know that there's 90 grams of zinc nitrate.
Mhm.
So we have to calculate, we have to determine the molar. We first need to know the formula for zinc nitrate, and then convert that to the number of moles. So zinc nitrate is ZnNO32. So we need to get the molar mass of that.
So 141. Wait, no, that's not right.
Close. I mean, it's a little bit more. You
Yeah.
got,
Oops. I
you make
forgot.
sure you get 2 N's and 6 O's.
189.
Yes.
Okay. So that's 0.476 for the.
Okay, so that's our numerator.
Mhm,
And I'm just picking these letters, Y liters.
mhm.
0.6 molar equals that. So you're solving this equation to get Y out of the bottom. You multiply both sides by Y. So it becomes 0.476 equals, I'm sorry, let me go it the other way. 0.6Y equals 0.476. Divide both sides of 0.6, 0.6. And you have your Y value.
0.793.
Yeah, 0.793, and that's your liters.
Mhm.
So it might be 793 milliliters. Let's just confirm that that's kind of what they're looking for. Yep. What's
Alright.
interesting is the answer to 13.
Mhm.
Or that was 16, right?
15.
15. Yeah, 15 is 792. The answer to 13 is really similar. Okay, that must be unrelated. All right, let's try at least a couple more here.
Mhm.
All right, how many kilograms of calcium acetate are needed to make 1,250 milliliters of 2.6 molar solution? If you haven't figured it out by now, 2.6 molar X moles. This time we do know the number of liters. It's 1.25 liters. So first calculate the number of moles. Could you do that for us, please?
Yeah. 2.08.
So you're multiplying both sides by 1.25. So to get bigger,
Oh yeah.
the number of moles.
So 3.25.
That sounds better. 3.25 moles of calcium acetate. So we now need the empirical formula of calcium
Mhm.
acetate. And well, that's a big one. So I don't know how you're supposed to know this. Maybe it's given on the back, and maybe
Yeah,
that
we have
the molar mass is also given. Maybe that's what I was seeing.
no, but I. Okay. Oh, okay.
The C4H68O4.
I got 99.
Yeah, you got 4 C's, right? 6 H's, 1 Ca, and 4 O's.
Yeah.
I got a little bit bigger. I'm using the kind of a calculator here. I got 158.
Okay, that's probably right.
4 C's, that's 48. 6 H's is 6. Ca is 40. And then O4 is 64.
Oh, I see. Oops, I put yeah. So 3. 513.5.
It's quite a bit. Now that's in grams.
Uh-huh.
So when you convert to kilograms, there's 1,000 grams in 1 kilogram.
Mhm.
So it'd be about 0.514 kilograms. And that is correct.
Perfect.
All right. Try another one here. All right, what is the molarity of an 1874 milliliter solution with 198 grams of iron 2 oxide? So we've got to take that 198 grams of iron 2 oxide.
Mhm.
And I don't know how many O's, but I'm guessing you have maybe one of each. It's another formula.
Oh yeah, let me look. Mm,
So it's just FeO.
yeah.
So you need the molar mass grams FeO, mole FeO.
Okay, so um, is it 128?
There's the 2 is the charge, so it's there.
Oh.
It's just one Fe and one O.
Oh, okay. So 72.
Yes. Okay, so now that gets you the number of moles of this.
2.75.
Okay. Yep. So you have 2.75 moles
Mhm.
and number of liters 1.874 liters, and that will give you the molarity.
1.470.
Okay, let's take a look here. The bottom 1.47.
Mhm.
That will do it. Yeah. Okay, so you're going to have to talk to your teacher or someone in class that knows this stuff. I really
Yeah.
don't have much advice for the 13, 14. I don't think they're difficult. I think they're like
Yeah, I don't
you,
think.
you get a number and then you divide it by another number and then you got the answer, but I
Yeah,
have no idea. And you can see like 20 is like that,
yeah,
21, things like that. So at least you got a good firm
yeah.
understanding of this molarity, moles per liter business and some conversions like that.
Mhm.
So I do have some time later in the week. If you do want to get another lesson, try my best to help here, but go ahead and stop.